This section will highlight some current research and technologies in alternative energy sources and reducing our carbon footprint. You will see that some resources developed from food production systems can help address wicked problems in sustainability. Tell me a little bit about your switchgrass research.
Yeah, we are just standing in front of the switchgrass in Michigan. It's aeroponically grown. It's basically, this is a part of our NSF project. It's a future manufacturing project. We're talking about the circular economy. Basically, we can extracting nanocellulose crystal and the graphene from the lignin, which is in this plant contains about 40 to 50% cellulose, and then 30 to 40% of the hemicellulose, about 20% of lignin. Basically, we are extracting the carbon material from this grass, and we use those the carbon material to make a 3D printable ink. Actually, then we can actually develop the 3D printable ink, and then you can print your own biosensor. And then sensor we are developing to actually monitoring the nutrient in the soil and in water. Especially in this kind of a system, this is aeroponically grown, and then basically from the reserve bucket, we are controlling the nutrient, and then using those sensors, we can adjust the nutrient, and then actually those sensors basically optimizing nutrient level from this grass. While we are doing, actually, we are changing the nutrient concentration in the bucket, and which is feeding this plant, and then we see how we can improve the extraction rate of the cellulose and the lignin, which is a target compound. Basically, all we need coming from the plant, even for the agriculture, is basically we're talking about the circular economy. We don't have to rely on carbon basic chemistry from the petroleum. Basically, we can get all we need from the plant material. This is our project about future manufacturing project. We call basically in the future petroleum is going to be gone, and no more petroleum. We still need a lot of carbon based chemistry, and we can get those from the plant. Is actually we are preparing for the future right now. It's all about the sustainability, because we don't. This is renew itself. Petroleum, it doesn't renew itself, but this plant is growing every year, coming back again, and then basically, just continuously we can have carbon from the plant material we're growing from agricultural land.
Okay, so backing this up and kind of helping me break this down, we can sequester the carbon from these plants and print. We create an ink, and we print this 3D printing of a sensor that then monitors the nutrients in the ground? Is that
ground and soil, whatever, the indoor production, outdoor production.
Okay, and then so how does that eventually replace our petroleum products? Tell me how that works in the process.
All the carbon material we are currently using, whether you are clothes and my pants and shoes and plastic, everything coming from the petroleum right now.
Okay.
And nylon, polyethylene, everything coming from the carbon from the petroleum. But you think about the carbon, where does it originally stored in petroleum or coal? It's actually old ancient plant and ocean plankton algae plants is actually sequester carbon from atmosphere, and then they turn it into the oil or coal. And then we are extracting those oil and coal right now to making different chemical. Basically, those one actually serve as a carbon backbone, flatbone chemical. But now here, but those are actually from the plant material, but it's not a human time scale. That's why we don't call that actually renewable. But this plant growing right now every year, they make a huge biomass. Basically, plant does the photosynthesis, and most people we concerned about the high concentration of the CO2, right? Right now it's about 410 parts per million of the carbon dioxide in atmosphere, and used to 20 years ago when I started, about 340 parts per million. It's already, we got almost 100 parts per million, which we are concerning as a carbon dioxide greenhouse gas. But this plant, when they do the photosynthesis, they sequester carbon. and then those carbon is actually the raw material to produce the glucose. The glucose is the sugar. The carbohydrate is the backbone chemical for all the human lives. Actually, you eat every day is a carbohydrate. It's basically plant synthesizes through the carbon, photosynthesis as they fixing the carbon dioxide in the atmosphere. And then plant depends on what kind of plant. Corn, they put a lot of energy in corn grain to make a starch. But this perennial crop is actually they put a lot of those carbohydrate in their biomass, which is it's all we call is the plant biomass, which is about 40 to 50% is the cellulose, which is all polymer of the glucose, and then 30 to 40% the hemicellulose, which is a polymer of xylose and glucose, all different kind of carbohydrate, and also the the carbohydrate, which is the polyphenol phenol structure of the lignin. All those are coming from actually carbon dioxide from atmosphere, and they produce it through the photosynthesis. And then this specific project is actually extracting the nanocellulose crystal from this cell, the plant cell, which is coming from the cellulose, and the graphene is coming from the lignin, non-carbohydrate polymer lignin, and those materials actually electrochemical, and the chemical engineer is using those carbon compounds to make a 3D inks actually.
Oh, wow. So unlike, if I'm understanding this correctly, then unlike our using petroleum, that's once it's extracted, it's gone.
Yeah.
This is renewable. This regenerates
Yeah,
itself
exactly.
because these plants.
That's the point. If we don't extract the petroleum oil, they stay in the ground. And as we burn and use it, carbon dioxide goes to the atmosphere. And then basically they're increasing the carbon dioxide in the atmosphere. But this plant is actually not taking carbon dioxide from the ground. They actually take away from the atmosphere and reducing the carbon dioxide. And then we just recycle those.
So we get a double benefit out of your process.
And also, as you see, this one has a lot of root biomass, right? And this plant is actually, when they produce 1 ton of above ground biomass, and then they also produce 1 ton below ground biomass. All the roots is also carbon. Actually, a lot of carbon dioxide, actually, we put them in the ground. And then we sequester, increasing soil organic matter. That's another benefit about this perennial grass, is actually.
So not only are you creating renewable energy source, you're taking carbon out of the air, carbon dioxide out of the air, you're also improving the soil, the health of the existing soils through these plants.
Yeah, I think plant material is a true carbon negative source. We talked about the solar energy, wind energy, all those, but those are actually carbon neutral because we're not really reducing the carbon dioxide in the atmosphere. Rather, we stop producing carbon dioxide. But this plant is actually actively taking CO2 from atmosphere. Actually, this is what we call the carbon negative, because actually reducing the carbon dioxide.
This section gave you a lot to think about, and it's great news. We can utilize technology and research with plants to improve soil health, reduce pollutants in the water system, and in our atmosphere. Certain plants in our food production system have the capability to serve as a carbon negative renewable energy source, and that technology is available today. Which raises the greater question: what are the obstacles preventing our global society from prioritizing this technology?